Good morning, students.
Morning,
Good.
morning.
Morning, sir.
Good. Let me just. But can see the screen and hear me clear, right?
Yes, sir.
All right. So continuing with the revision on quadratics. All right. Basically, I want to get some practice on what we covered in the week. But we're going to start out firstly by going through this exercise that we did in the class. All right. So past paper question, and as I always say, if you can do it in the class, then you can do it in the exam room. Our first objective is to be able to do it in the class, in the classroom, all right? So let me just work through this question again, all right? Because we're going on to new material tomorrow. All right, so represented with this graph, it's a graph of a quadratic function, that's what it says. The diagram is a sketch of a quadratic function, and this is that function. All right, and all the critical features of this quadratic function are shown. This is the curve right here, and all the critical features are shown on it. So we have the A, which we know is a y-axis intercept. It's one critical point. We have B, which is that vertex turning point. It's another critical feature. We have these 2 points, which are the x-axis intercepts, or we call them the roots. And then we have this vertical line passing through that vertex point. And so we know that this is a line of symmetry. So the question is a knowledge-based question. It's testing our knowledge of certain things. And the question said, we are to determine the coordinates of each of those points, A, B, C, and D. And then we are to give the name or phrase which is used to describe each point. And after that, we are to write down the name and equation of the vertical line passing through B. That is this vertical line, which you know is the axis of symmetry. So the more things you know, the better. I always say, if you know your stuff, then you don't have to think. All right, the majority of questions in CSEC is such that if you know your stuff, if you know what you're supposed to know, then there's no need to think, you just do. All right, so let's see how we could approach this now, using our knowledge. So the function is this one. F of x equals 2x squared minus 5x plus 2. All right. This function, the a, b, and c from this function, from the standard form. This is the standard form. A is the mic, please, meet the mic. The a is the coefficient of x squared, which is 2 right here. It's 2. The b is the coefficient of the x. This is the x. This is the coefficient of x with the minus sign. So that's negative 5. And the c is a constant term right here. Term it without the x beside it. Let's call it that. That's a 2. It's a positive 2, so let's write that 2. All right. This question is not asking us to complete the square. It's not asking us to factorize. It's asking us to find the coordinates of the points A, B, C, D, and then name each point. All right. So what is A? Let's do them one at a time. What is the point A? I want to give the name of the point A first. This point right here. The point A is a point of intersection with the y-axis. It's a point of intersection with the y-axis. It is called the y-axis intercept, or we can simply call it the y-intercept. So it's a y-axis intercept. Look at how the word intercept is spelled. So it's a point of intersection with a y-intercept. It's a y-axis intercept. That's the name of this point. That's what that point is called. And the coordinates of that point always carry the values 0, C. Which C? The C value from here. Why is that? Because this point is on the y-axis. the x value is equal to 0 at all points on the y-axis. So at this point, the x value is equal to 0. And if the x value is 0 on this function, then this will be 0, that will be gone. This also will be 0, so this will be gone. And so the function value, which is the y value, will be equal to 2. That's why we have c value, which is the c value 2. And so the point, therefore, is 0 and the c value, 0 and the c value, because this will be the c value now. So therefore, this point A is the point 0, 2. That answers the first part. We have given the name and the coordinates of the point A. All right. Then we're going to talk about the point B, which is right at the turning point. And it's actually a minimum turning point. So mathematics is the most exact science. And so if we can give the full details of this point, we do that. So we are not going to just say it's a turning point. Because we know it's a minimum one, we should go and say it's a minimum turning point. So the point B is a minimum turning point. It's also called the vertex. It's another name for it. The quadratic function graph. That turning point is also called the vertex. Now, we have to get familiar with all these terminologies because we don't know which word they will use in a question. All right, so we have to introduce all of them. Mute your mic, please. Mute your mic. So we have given the name or phrase of the point B. It's a minimum turning point, which is also called the vertex. And then we now need the coordinates of that point. So in our program, in our class, we refer to that point B in terms of the coordinates. We call the coordinates xt, yt. The letter T stands for turning point. And so this would be the x value at the turning point. And this would be the y value at the turning point. So we are now tasked with finding what this value is and what that value is. Now, these values, as we have learned, can be calculated using the A, the B, and the C from the standard form. It's a nice quick way to work it out. And the method that we learned this in class is such that we are able to actually calculate that x value at the turning point and the y value at the turning point using a formula that uses these values, A, B, and C. All right, using formula that uses those values. All right, so the xt1 first, the xt that we need here. The formula for that one is minus b divided by 2a. And so it's important that we get the a, the b, and the c right up here because we're going to be using them to calculate the values down here. Note carefully that the b right here is a -5. And a lot of persons make the mistake of not putting this negative and of not considering the fact that you have a negative here, and then this b actually is -5. And so we have to learn to be careful. So if I were to put down this negative first, that would be it. And if I were to put down the value of b, then I would have to put down -5 for the value of b. And so that's negative there first, and then I'm putting down -5 for the b. I can leave it like that, or I can bracket it. So this is the b. This right here is the b. All right, and then we're dividing that now by 2 times a. What is the a value? The a value is this 2 right here. And so it becomes 2 times 2. Then we all know that negative times negative is a positive. So this becomes a +5. And this becomes 4. So it means that this is the x value at the turning point, which is going to go right here for the xt. All right, so we can actually start writing that. Let me just shift this down a little bit. Because I'm going to put the answer right here. So this point becomes b. The x value there is 5/4. We now need to work out the y value to go here. The y value now can be calculated using the formula. And so remember now, this formula is a must-know formula. If we're going to be using this method to do it, you must know this formula. The more things you know in math, the better. That's a must-know formula. And we're going to write the formula for the YT, you know. So the YT value, the value at the turning point, the Y value at the turning point. Formula for that one is 4AC minus B squared divided by 4A. Remember, the A, the B, and the C comes from the coefficients in the standard form. This is the standard form. And we have learned how to pick out these values, A, B, and C. All right? So we're going to drop those values inside here now. All right, so that becomes equal to 4 times A. What is the A? Remember, the A is 2 right here. This is A. A is 2. Times C. What is the C? The C is also 2 right here. The C is also 2. So I'll put another 2 here. Minus. Now, this minus is this one. And it is not being squared. And so it's going to stay positive. This square that we have here is not on the minus. It is only on the B. The square is only on this B. The negative is not squaring. So what is the B? The B, remember, is -5. So I'm going to put back the -5 again and square it. So this is the B squared that we have here now. And we're dividing all of this now by 4 times A. And the A we know is 2. The A up here is 2. All right? Let's continue. There's a matter now of simplifying this. And we have to be careful with these negatives here. All right, remember, this negative is not squaring, but this one inside here is squaring. So all of this will become a positive 25. All right, so the YT now becomes, this is 4 times 2 is 8, 8 times 2 is 16. This becomes 16. This minus, I'm putting it back here first because this is not squaring. And then this -5 squared becomes 25. As the same as saying -5 times -5 becomes a positive 25. So remember, this minus is this one. And we're dividing all of this now by this 4 times 2 is 8. And if we simplify, 16 minus 25 is actually -9. Divided by this 8 under here. And so that's the YT value. And then this YT value now is going to go right here to replace this XT, this YT value. And so I'm going to put that value here, -9/8. So that is the B. We are finished now with the B. All right. And this is another must-know formula. This is another must-know formula. If you're using this method, that's another must-know formula. The more things you know, the better. All right. It's a formula. There's not a formula I'm going to teach in this program that you have to know now. But these two, yes, because they will not be on the formula sheet in the exam. All right. So when we use this method, we have to know those two formulae right there. All right. So that's A and B so far. Everybody good so far? Everybody okay?
Yes, sir.
All right. Let's talk about C and D now. Now, C and D really is the same kind of point, you know. So we're going to actually find them the same way. So C and D is the same kind of point. It's two of the basically, it's basically two of the same kind of point. All right, same kind of point. So they are actually called the roots. They're a point of intersection with the x-axis. So let's talk about C and D together now. So C and D, putting them together. Now, first, they are called the roots. The points of intersection of a graph with the x-axis are called the roots. And also the x values at these 2 points, they are also called roots. So the word roots has a double meaning. The physical points are called roots, but the x values at those 2 points on the x-axis are also called roots. They can also be called the x-axis intercept because they are clearly the points of intersection with the x-axis. So just as though this is the y-axis intercept, these two can be called the x-axis intercept. We can call them that as well. So they are also the x-axis intercepts. X-axis intercepts. So that's another name for them. What do we know about those 2 points? At those 2 points, the y value is always equal to 0. At those 2 points, the y value is equal to 0 because they are points on x-axis. All points on x-axis, the y value will be equal to 0. In fact, the equation of x-axis is y equals 0. All right, so we know that. To find those 2 points, we must know that we solve the equation. The equation that is associated with this function is the one where you put the expression now equals 0. That becomes the equation. When you solve this equation, that's a quadratic equation related to this quadratic function graph, it gives us these 2 points. The x values that we get when we solve this equation, they are called roots as well. And they are the x values at the point C and D. So now it's a matter of just solving that equation. All right. So we know to find those 2 points, we have to solve the equation. We have to solve the equation. All right. We have to solve the equation 2x squared minus 5x plus 2 equals 0 because the y value there is 0. So it's like he equated this as y to be equal to 0. All right, but we don't have to get into the long explanation. Just know that if you want to find the roots, just solve the equation. All right, and the equation is when you put the expression equal to 0. All right, so now we're going to solve this now, this equation. And we have 2 ways to solve it. We can solve it using a quadratic formula, or we can solve it using a factorization method. All right, most persons in the class the other day use the formula method. But I'm going to use a factorization method for this one, just to get a chance to practice factorization. Also, there's another question here that will require the use of the quadratic formula. And so we get to use the quadratic formula in this exercise anyway. So let me use factorization for it. All right. So I'm going to solve this now by factorizing the left side, which is the quadratic. So how do we factorize? We factorize this expression by first finding a way to split that middle term into 2 x values. Split out, so we want to split out the whole thing from 3 values out into 4 values. And there's a nice method that we use to find what we split this middle term into so that it becomes friendly to the factorization. And it is that we multiply the 2 n values first, the 2 n coefficients. Some people say they multiply the a times the c. All right, so multiply the 2 times the 2, and this is equal to 4. Then what it is that we want factors of this 4 that add to the middle coefficient, which is -5. We want factors of 4 that add to -5. So let's focus now. Some person might say, okay, how come we have 4? I want factors of 4 that add to -5. Remember, 5, this 4 right now is a positive value. And factors of a positive value is either 2 positive values or 2 negative values you multiply. Positive time positive will be positive, negative time negative will be positive. So since you want factors of this positive 4, you're either going to use 2 positive factors or you're going to use 2 negative factors. Since we want the sum to be -5, it means then we are going to have to use 2 negative factors of this 4. 2 negative factors of 4. That's what we're going to have to use. All right? So let's go. 2 negative factors. So let's test the factors down here. If you can't see what they are right away, you can go down the list of factors. First 2 factors of 4 are 1 and 4. Make both of them negative. When we make both of them negative, and then you add them, you actually get the -5 that you want right away. Because -1 and -4 is -5. So it means then we're going to split this -5x into -1x and -4x. Or you can put the -4x in front. It doesn't really matter. All right? So let's go now. So what I'm going to do, let me use a different color. I'm going to take this -5x and I'm going to split it using these. All right? So that quadratic expression is now going to become 2x squared. This comes back unchanged. Then this -5x is split out into -1x and -4x. The -1x is just -x. And I can put the -4x in front. It doesn't really matter. But I'm going to put the negative 1x. Let's put the 1 on it this time. I could have just put negative x in there, guys. It's the same thing, but I'm just going to put the negative 1x this time and the negative 4x. This is just to show that we are using these two values to split it out. So it's negative 4x. So I always kind of double check this thing, that what to split it into right here would have given us back this negative 5x. Always do that check. Because negative 1x and negative 5x would have given, negative 4x would have given back the negative 5x there. And then this value now comes back unchanged, that's plus 2. All right, so let's put back the plus 2 now. And all equals 0. All right, remember, we're just trying to factorize this thing. So now that we have broken it out into 4 terms, we kind of do a thing of factorizing the first 2 terms and factorizing the second 2 terms. That's what we kind of do. We have to go for the highest common factor. So if we focus on the first 2 terms, we're looking for the highest common factor of those 2 values. The highest common factor right there right now is just an x. So we're going to factorize out an x from these 2 values. X divided out of this leaves us with a 2x. X divided out of this leaves us with a negative 1. Then you must have the same thing in the bracket over here when you factorize these 2. So what I normally do to ensure that I have the same thing in the bracket is to actually write back the bracketed term first. So I'm going to write this back first over here, which is the 2x minus 1. Then I need to know what factor goes inside here between. So it's either a plus value, plus some number, or minus some number. You have to put the plus or the minus here. What number is it? You can know that number by, for example, dividing this positive 2 by this negative 1. Positive 2 divided by negative 1 is negative 2. So I know that the number inside here is negative 2. Or you could divide this negative 4x by this 2x. And that's again with the negative 2. So you know that these 2 values factored by negative 2 leaves us with that. So the factor is negative 2. And look, I cannot just put 2. Cannot just put a 2 here. I have to put the sign in front of it, which is negative 2. And all of this is equal to 0. Then now we have this 2x minus 1 as a common factor. Right? And so it's the x and the minus 2 times that common factor. And so we can put them together and it becomes x minus 2 times that common factor, 2x minus 1, and that is now still equal to 0. And so now we have factorized the expression. This original expression up here has been factorized to this. All right? So now that we have it factorized and we have the product of 2 factors equals 0, then it is either this factor equal to 0 or this factor equal to 0. All right? So if you imagine that this factor equal to 0, let me write it out this time. X minus 2 equal to 0 or 2x minus 1 equal to 0. Now, this step is not absolutely necessary because you can actually write the answers from here. But just to show you this time, what you're considering is either the x minus 2 equal to 0 or the 2x minus 1 equal to 0. Because if the product of 2 numbers equals 0, one or the other must be 0. All right? So if the x minus 2 is equal to 0, to make x a subject, we would transpose the 2 over here and becomes a positive 2. So this is giving us a root of x equals 2. That's one of the 2 roots in them. And then for this one, if 2x minus 1 is equal to the 0, just think of it. The x would be equal to, we would transpose the 1 first, the negative 1 first, sorry. We transpose this negative 1 over the equal sign first and get a positive 1. And then we take this 2 that is multiplying the x and divide it under the 1. All right, that's a shortcut way of doing it. So that becomes a half. So these are the 2 root values. But the question asks us to write the coordinates. See? Coordinates. Coordinates are a plural word. So we have to give the points with the 2 coordinates. And note that this x value is smaller than this x value. right? And if you look at the graph, you have 2 points, everything is important. The x value at this point must be less than x value at this point. So this must be the one where x equals half, and this must be the one where x equals 2. I will know that at both points, y equals 0 at both points. So that's how we're combining them now. So we're going to say then, this one is for C. So the coordinates of C, I put in the x value first in the bracket at all times. X value at C is a half, and y value at C is 0 because on the x-axis. So this is for the point C. Then this one is now at the point D. So D now becomes the point. The x value at D is this 2, and the y value at D is 0. So those now would be the coordinates of the points C and D. C and D. And that is how that part will be found. I'm taking my time at this one, guys, because I'm moving on to a different topic tomorrow. All right? I'm moving on to a different topic tomorrow, so I'm taking my time with it. But okay so far? Very good?
Yes, sir.
All right.
Yes, sir.
So that's all the points so far. And the next part of the question now was about this vertical line here. And we see it's a vertical line passing through the vertex, the turning point. And so it is a line of symmetry or axis of symmetry. What this line does is actually divide the graph into 2 equal halves, such that the half over here is a mirror image of this half over here. And it is such that points on this graph, on this side, is the same distance of the axis on this side. Any 2 random points. So for example, these 2 roots are the same distance of the axis. Whatever this point root is, the same distance from the axis. I can check it and show you. Let me show you with this one now. Remember the axis right here was what? 5 over 4, right? It's a 5 over 4. This point right here is 5 over 4. So it means that the x value at this point is 5 over 4. Right here is 5 over 4. 5 over 4. Right here, the x value is a half. Right here, the x value is 2. So to prove that this is exactly between them, it means that if I average these 2 values, I am supposed to get the 5 over 4. Right? Because the distance from here to here, the distance from here to here is the same distance to this root from the axis of symmetry. So it means that if I average the 2 roots, I'm going to get the x value at the turning point. So that is something else that is good to know. If you want to find the x value at the turning point, you can actually average the 2 roots. But the turning point is equidistant from the 2 roots. I can prove it down here. Just extra work. Right? If I average the 2 values. So if I take a half plus 2, and I average them, then I divide that by 2, it's going to work out to 5 over 4. Let's prove that it works out to 5 over 4. How can we prove that it works out to 5 over 4? All right. I can add these 2. The half and this 2 gives 2.5. 2.5 is the same as 5 over 2. Because this 2, let me show you, this 2 right here, this 2 right here is the same as 4 over 2. So this will become a half plus this 2 is the same as 4 over 2. See, 4 over 2 is still 2. All of that divided by this 2 equals, the numerator now becomes 5 over 4. That's 1 and 4 is 5. 5 over 4. That's the numerator. 5 over 2, sorry. The numerator all over this 2. And to divide by 2 is the same as to multiply by a half. So this works out to be 5 over 2 times a half. To divide by 2 is the same as to multiply by a half. By cutting something in half when you divide it by 2. Look at it that way. So this works out to be 5 times 1 is 5. 2 times 2 is 4. So you see you get x value at the turning point. How did we get it? Average root. So you can remember this now. xt, another way of finding xt is to average the 2 roots. R1 plus R2 divided by 2. So now you learn something new in this class. That's why you must attend. That's another must know. The more things you know, the better. So if you know the two roots, you can actually find the x-value at the turning point by averaging the two roots. All right, so we did not do this in the class, but I'm showing it to you now. I can't teach you everything all at once. It is progress before perfection. So this is the opportunity now for us to introduce this new way of finding xt, if you know the two roots. So that's another way of finding xt. Apart from the fact that xt equal minus b over 2a, yes, that's another way to find xt. Average the two roots, because the x value at the turning point is equidistance between the two roots. All right, so that was a digression a little bit just to emphasize this thing. All right, but understand that, by the way, everybody go with that? Everybody okay?
Okay.
All right, so remember this one, please. Make a note of it. Remember, because some questions you'll get where this will become very, very useful. The more
Sir,
things,
sir,
yes,
sir, can we do the last part, please?
which last part? Right here, sir?
Yes, sir.
Not a part of the question, you know. I'm just showing you that if you average two roots, you're gonna get x value at the turning point. We already know that the x value at the turning point is 5 over 4. We did it from the first part up here. And because
Yes.
I'm doing part of the question now, just taking the opportunity to show you something that was not really a part of the question. I'm just taking the average of the two roots, right? One root was a half and the other root was 2. We just calculated them a while ago. See them here? The 2.5. If I average a 2.5, if I average a 2.5 by adding them first and then dividing them by 2, that's what you're gonna get. X over 4. You can actually put this in the calculator and you're gonna get the same thing. But I don't want to spend time on this and working that out because I don't want to digress on the purpose of the class. Right? But if you like, you can just put this in the calculator and work it out. Let me bring up my calculator and see. Let me see if I have my calculator up here. Let's see if I have it here. Let's see. I don't have it. See it here. Here's my calculator. I'm going to average the half and the 2 and show you that it becomes 5 over 4. So if I do an average, if I do a fraction, and I do a fraction first, which is a half plus 2. That's the sum of the two roots, half and 2. But I'm averaging it, so I have to divide that now by 2. So that's become 1.25 as a fraction. As a fraction, it is this 5 over 4. So this expression that I have up here, which is a half plus 2 over 2, is equal to this expression right here, which is 5 over 4. As a decimal, it will be this one, 1.25. As a mixed number, it will be this one, 1.25. All right? So that is that. All right, so I just wanted to know that if you average two roots, you're also going to get x value at the turning point. That's just something I'm just introducing now. The new thing. All right? Okay?
Yes, sir.
All right.
Yes, sir.
Good. So now we're going to talk about the vertical line. The question asks us about the vertical line. Easy thing. This vertical line in this graph. So what I did a while ago was not a part of the question, just something that I wanted to show you. All right? So that vertical line, let's just call it V line for now. It is called the axis of symmetry, the line of symmetry. A line of symmetry is like a mirror line within a diagram that divides a diagram or divides an object half and half, and one half is a mirror image of the next half in that line of symmetry. So line of symmetry is like a mirror line. Sometimes they call it the line of symmetry, same thing. And the equation of it is that x equals the 5 over 4. Let me write it. This is x equals whatever the x value is at the turning point. And x value at the turning point happens to be 5 over 4. And so it's x equals 5 over 4. Now, some persons will put in 5 or 4 as the equation. This is not an equation. This is an equation. This is actually an equation. Yes, you have equations like that. Equations of a line. You can tell you from now, all vertical lines have an equation looking like this. Let me show you quickly. More math equals better math. Let me show you quickly. All right, we're going to do this over the topic of coordinate geometry, but I can show you. Now, if this is the x-axis and the y-axis, let's say I put on some points on this graph. So let's say that this is 1, this is 2, this is 3. Let's say that this is -1, -2, -3. Then let's put some horizontal marks as well. Let's say this is 1, 2, 3. This is -1 and -2. Now, this is the y-axis.
On the Thursday.
And this is the x-axis. Eh?
Want to come on soon.
Mute your mic, please. Mute your mic. Mute your mic. This y-axis is vertical. The equation of it is x equals 0. As a vertical line passing through where the x value is 0. This vertical line passing through 1, like this, is actually x equals 1. This vertical line passing through 2 right here, the equation of that line is x equals 2. This one, the one passing through here, the vertical line passing through here, is x equals 3. Over here, put some vertical lines over here as well. I'm just going to do one more. For example, passing through is -2, like this. A vertical line passing through -2, which is parallel like the y-axis. That line is x equal -2. Notice all those vertical lines carry the same kind of equation. X equals a number. Those are the equations of those lines. So vertical lines will always carry an equation, x equals a number. And a way to remember that is to say that the y-axis is x equals 0. So lines that are vertical at the y-axis will be x equals a number. Let's talk about horizontal lines. I'm going to put those in purple. So the first horizontal line is actually the x-axis. The equation of the x-axis is y equals 0. Y equals 0 is the equation of the x-axis. It's the first horizontal line. All horizontal lines will have an equation similar to this. Y equals some number. And so the horizontal line passing through this 1, like so. This line is the line y equals 1. That's the equation of that line. The line passing through 2, that is horizontal, like this. That line, the equation of that line is y equals 2. The line passing through 3, that is horizontal, like so. The equation of this line passing through 3, horizontal line, is y equals 3. And then we can come down here now where the x values and y values are negative and put a horizontal line through this one, for example, and get the trend. This one, if we draw it right through, this one is a line y equals -2. So horizontal lines will always have an equation. Y equals a number. Vertical lines, x equals a number. So one way to do it is to remember that vertical lines have an equation x equals a. X equals a being a number. But horizontal lines like this have an equation y equals b. So all vertical lines will have an equation looking like this. All horizontal lines will have an equation looking like this. The y-axis in the axis of symmetry over here is a vertical line. So the equation of it must be x equals some number. What number is that? The x value at this point. X value at that point is 5/4. Because all points on this vertical line is going to have the same x value. That's why that is the equation as well. All right? So that's the equation of the axis of symmetry. Just wanted to spend some time on that a little bit. But I go to that.
Yes, sir.
All right. Learning stuff, guys. Progress before perfection. A lot of things to learn between now and the exam. Taking it in stages. All right, so that basically finishes number 1. All right. Let's go on to the next one. Number 2. Right here, which was to factorize this and to factorize this. From factorization, easy questions. Let's look at this one first. So I see 4 values there, so I know it's a factorization, what we call a factorization by parts, or a factorization by grouping. All right. So, and when you finish this, normally you get a double bracket answer. You have to know that. Normally you finish this, you get a double bracket answer with 4 values like that. All right. We get those factorization by parts, grouping question. All right. So let's rewrite it. So it's 3g minus 3t plus 2mg minus 2mt. So normally this question, you want to ensure that the values are set out in a friendly order. So what I normally do is look at the first 2 terms and say, okay, what would I factorize the first 2 with? I would factorize it with the 3. And inside the bracket, I would have the g and then the t. So the g followed by the t. So I'm looking over here now to see if the g term comes before the t term, which they do. This is the g and then that is the t. So it means to me, it tells me that the values are already set out in a friendly order. I don't need to rearrange the values. I can proceed with the factorization as they are. So the highest common factor in these first 2 terms is 3. 3 divided out of this leaves me with a g. 3 divided out of this leaves me with a negative t. What do I always say? Put back the same thing in the bracket over here if it is to work that way. So I'm going to put back the g minus t first. Then I look, what must go in beside here? Plus something or minus something. Let's look at it. Oh, you can know. You can divide this plus 2mg by this g. You divide them. You see that you're left with the plus 2m. Plus 2m. Or I can divide this minus 2mt by this minus t. The minus cancel the minus and the t cancel the t. So I'm left with this 2m and a plus 2m again. Any way you want to look at it, what comes in here is a plus 2m. So then the next step is that the g minus t is my common factor and they are being added with the 3 and the 2m plus 2m. So the 3 and the plus 2m becomes one factor like this, 3 plus 2m. And the other factor is the g minus t. And that is it. Some persons do it and get the g minus t in front times the 3 plus 2m. Doesn't matter. It's correct, same thing. Just like they are written the other way around. But those are the 2 factors right there. All right, nice and easy. Then we have this one. A lot of persons run into some problem with this one, but no problem. We're learning still. This is the time to run into problems if you're going to run into problems. We don't want to run into problems in the exam. So we'll learn from our mistakes here. All right. So we have 3x squared minus 3. So every time I'm doing a factorization, and I say 2 terms, with a minus sign between them, my brain automatically starts thinking about the difference of 2 squares. So I'm checking to see if they're the difference of 2 squares. Right now, they are not the difference of 2 squares. We're talking about perfect square numbers now at this level. So this 3 and that 3, they are not square numbers. They're not perfect square numbers. And so we don't have the difference of 2 squares right now. What we have is a common factor of 3. So what you're going to do, you're going to factorize the common factor first. So you factorize away the 3. 3 out of this leaves me with the x squared, clearly. And then this divided by 3 leaves me with a negative 1. And then once you do this factorization, a lot of person left it there now. You have to always check what left in here can be factorized any further. And your brain must be thinking about the difference of 2 squares every time you see factorization with a minus there and you have a square term there. For some reason, people tend to forget that 1 is a perfect square. It's a first squared number. So the squared numbers are 1, 4, 9. What is it? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. People tend to forget this one. People tend to forget that one. This is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared, this is 5 squared, and so on and so on. For some reason, people tend to forget that one. So 1 can always be written as 1 squared. We have to remember that, guys. CXC like to set this in factorization questions. So we have to remember these things. Comes with practice. And then you have the eye for it when you practice. That's why we have to encounter it a number of times. So this 1 is the same as 1 squared. But don't throw away this first factor. It must come back in the next line. It's the first factor from this line up here. So I'm going to write by the 3. And I'm just going to write this as the difference of 2 squared. I'm going to write it as x squared minus 1 squared. Because the 1 is the same as 1 squared, as simple as that. I now have the difference of 2 squares. Let's remind ourselves of the rule for the difference of 2 squares. So when you have the difference of 2 squares, like a squared minus b squared, this factorizes a minus b, difference of the numbers, times a plus b, sum of the numbers. And I was explaining to a student the other day that I prefer to write for you to write the a minus b first. Some teachers write the a plus b first, but I prefer when you write the a minus b first. And I'm going to take the opportunity to show you why just now. Why I prefer for you to write the minus first. Because it's basically, this is just basically the first level in a series of difference of 2 powers. This is the first one, where all of them begin with the difference of the 2 numbers. All of them begin with the difference of the 2 numbers. Just that C-sec will start with the difference of 2 squares. But the difference of 2 cubes, for example, a cubed minus b cubed. It starts with a cubed minus b cubed. It starts with a minus b times something. I'm going to show you in the next slide. I'm going to show you. Let me just finish this and then I'll show you what I'm talking about. So applying that rule now to this. And so don't throw away the first factor, which is the 3. And then these now factor out into the difference of the numbers, which will be x minus 1, times the sum of the numbers will be x plus 1. And so that is the answer, the factors of this one up here. Let me show you now the hierarchy for the difference of 2 powers down here, quick and fast, as a reason for us to start with the a minus b. So in the first level, apart from a minus b itself, we can have a squared minus b squared as the first one. We're not including a minus b, right? Which is b to the power 1, which is just going to give it a minus b times 1, right? We're not starting with that. Let's start with a squared minus b squared. That is a minus b times a plus b. The next layer in this series is a cubed minus b cubed. Just that you won't get this at C-sec to factorize or expand. Yeah, to factorize. This would become a minus b. Start with a minus b as well. And then inside the bracket here, I would have a squared plus ab plus b squared. That's what I would get if I were to factorize this as the difference of 2 cubes. So it starts with a minus b as well. Then I can have a to the 4th minus b to the 4th. This again starts with a minus b. And then inside this bracket now, I'm going to start with a cubed. The power of the a is going to go down to a squared. Then the b will start. Then the power of this drop again to a. And the b comes up to b squared. And then I have b cubed. So it's like a pattern, like a number pattern. And I can continue on and on and on forever. I can go like this again. A to the 5th power minus b to the 5th power. If I go to the next layer, the next level of it. Again, this one starts with a minus b. And then inside here now, I would have a to the 4th plus a cubed b plus a squared b squared plus ab cubed plus b to the 4th power. This is what this one would be. All right? And so it is all a part of a series of a to the n minus b to the n. all of them start with A minus B and then continue to have some number of values inside here with pluses between all of them. All right? Pluses between all of them. And that's why I said, even though we are doing just this level at CSEC, I prefer when the students write the A minus B first. Everything is important because all of them in the series of difference of 2 powers start with A minus B. But understand that? But I go to that?
Yes, sir.
Yes. Just explaining why I say put A minus B first. Just in case it don't matter at the next level, yeah, you'll be already be familiar with putting A minus B first. The difference of the numbers first. All right, so that finishes that. Okay, then we'll come to this question, which was the last question on the activity. It told us to solve this equation, and then it said, giving your answer to 2 decimal places. Now, this one is a quadratic equation, just that it is in a basic form. Remember, you always want your quadratic to be equal, to set out so that you have the expression equals 0. But there's a reason for telling us this thing. For telling us to give the answer to 2 decimal places. It means that we won't be able to solve this using a factorization method. Because factorization method is used for the types that's gonna give you exact values answers, exact values. The answers for this is not gonna be exact for this one. Answers not gonna be exact, and this is why they are telling us how accurately we are to give our answer. And when that is the case, we use a quadratic formula. We don't use factorization. So this really means, this is a hint. This is like a hint. This is like a hint to say use the quadratic formula. So don't bother waste time trying to factorize it after you put it in the standard form. Don't bother waste time trying to factorize it. That's what it's basically saying. Use a quadratic formula. All right, so let me do it over here. So I have 3x squared minus 5x equals 6. We don't solve it quadratics at this level when you don't have the expression equals 0. So you want to transpose the 6. All right? So you're going to have 3x squared minus 5x minus 6 equals 0. So this up here is what we call a basic form. Is what we call a basic form of the quadratic equation. It's what we call a standard form. What we say? Don't solve basic. Don't solve basic form. Don't solve. Solve this one. Throw away this one, solve the standard form. So anytime you get an equation that's in a basic form, you want to use the methods that we learned to solve it. And the method that we're using to solve it are based on the equation being in the standard form. And I explained why already in the class. The quadratic formula was derived from an equation that was in the standard form. And even if you're using factorization, you want the expression to be equal to 0 by using that special property of the number 0. That special property of the number 0 is that if 2 numbers multiply together is equal to 0, then one of those 2 numbers must be 0. That's a special property of 0. That's why we need the expression to be equal to 0. And then when the equation now, so we're solving this now, the standard form. When the equation is in the standard form, we're able to identify correctly the A, the B, and the C. And don't get any of them wrong, because if you get the A wrong, or the B wrong, or the C wrong, then your final answer will not be correct. All right? So the A in this case is 3, which is the coefficient of the X. The B is -5, which is the the A is the coefficient of the X squared. The B is the coefficient of the X, which is the -5. not the second value, you know. A is not because it's the first value. No. A is a coefficient of the x squared. And B is not the second value, you know. B is the coefficient of the x. C is not the third value, you know. C is a coefficient, it's a constant term that has no variable on it. Right? So even if I rearrange these values and put it as minus 5x minus 6 plus 3x squared equals 0. Even if I wrote it in this way, the A would still be 3 because it is the coefficient of the x squared. That's why the x squared is now shown third. The B would still be negative 5. Even though this appears first, the B is negative 5 because it is the coefficient of the x. And the C would still be this value, even though it appears second this time, to still be negative 6 because the negative 6 is a constant term in the expression. So let us get that right. I saw somebody in the class messing that up in the classroom, all right? So I was taking the opportunity to remind us of that. And so B is a negative 5 here, and C is the negative 6. They're going to use a formula. I'm going to, again, say a mistake person is making with the formula. Formula, right, is that x is equal to minus b plus or minus the square root of b squared minus 4ac. And it is all, everything. This is very important, guys. It is all, everything over the 2a. So you're dividing the entire numerator by the 2a. The common mistake is for persons to put this part alone over the 2a, which is wrong. Let us not do that, please. It's a very common mistake. Why is it a common mistake? Because of how the formula is said, or it is verbalized. Formula is verbalized, minus b plus or minus square root of b squared minus 4ac over 2a. See that word over 2a? When people don't use the word all over 2a because they don't use this word, it causes persons to put just this part alone over the 2a. Let us not make that mistake, please. It is everything over the 2a. All, everything, all over 2a. Everything, the entire numerator divided by the 2a. So you have to work out everything on the numerator over the 2a. It's not just this part alone over the 2a, please. So I said it in the class not to do it, and still I saw some persons doing it. So this is because, you know, sometimes we learn something a particular way, somewhere else, and that correction is not made, or that correction is not seen to be made. And so you bring it in, even in a program that says, don't do it, and you don't forget. And that's why practice is so good. But sometimes if you practice the wrong thing, then it's almost like you have entrenched the wrong thing. And now to get the wrong thing out of you, to get the wrong thing out of you, you have to practice the right thing repeatedly. Repeatedly, like you're wiping out the wrong thing and implanting the correct thing. So once you discover a mistake that you're repeatedly making, it means that you have to do a lot of questions and do the correct thing repeatedly over and over again to start to deprogram yourself from the wrong thing and reprogram yourself for the right thing. Everything important. It don't make sense to have a formula to use and just use it the wrong way. It don't make any sense. We don't lose marks with those simple things, please. All right? So let's put in the values now. And then even putting in the values, persons making a few mistakes. Let's identify those mistakes and don't make them. All right? So let me do it now with the blue. All right. So I'm going to write it now. I'm taking my time with this thing because everything important. So it's x equals minus, then the b. So this minus is this one I'm putting down first. Then what is the b? The b is the whole of this negative 5. So I have to put negative 5 right here for the b, negative 5. I can leave it like that, but I can also bracket it. That's minus, and that's b, minus b. All right? Very important. So that minus becomes a plus. A few persons still not getting that. Then it's a plus or minus a square root, and then we're squaring the b right here. So we're squaring this negative 5. Some persons do this. I don't want anybody to do that. You're squaring the entire b. You see this expression right here? It only means that the 5 alone is squared, you know. Got to square it only on the 5, you know. To show that you're actually squaring the negative as well, you have to bracket it. This is the entire b. Everything is important. Everything is important. Don't put down something that is wrong on the paper. You are squaring the entire b. Negative 5 is the entire b. Is the whole b, the full b. All right? And then now we're going to minus 4 times the a. In this expression, the a is 3. Times the c. The c is negative 6. Some persons have the negative 6 here and still put 6 there. It's a negative 6 that you're putting there. And then remember, it's everything over the 2 times a. The a is 3. 2 times 3. This is where some persons come now and they do this. Because some persons do extend this down and put the 2a under here. So. And that is wrong. Don't do that. It is all over 2a. Everything over the 2a. So this is what you must have. Everything over the 2 times a, which is 3. Now watch me now. We have to be careful everywhere we see negatives, guys. So these negatives, you have to be careful with them. The negative here, you have to be careful with it. The negative here and here, you have to be careful with them. Most mistakes in maths are made with a negative sign, believe it or not. Most mistakes are made with the negative sign. When we learn how not to make mistakes with a negative sign, we will see our grades jump up significantly by just eliminating negative sign mistakes alone. Your grades will automatically jump up. But a lot of persons get stuff wrong because of the negative, the misuse of the negative sign. So you have to always be careful when you see negative signs. We must have what we call negative antennas, like you're looking out for it. Once you see negative, you become extra cautious. You should become extra cautious once you see negative, because you know that a lot of mistakes, people make a lot of mistakes with the negative sign. So you train yourself to be extra careful, extra cautious, and then to become normal for you. You want being cautious with negatives to become normal practice. Don't just run over it. Don't just move past it. You lock in, you focus a little bit harder, you take a little bit more care when you see the negative. You check and double check. And that is how you improve. And that is how you eliminate making the negative sign mistakes. All right, so let's go now. So this x then becomes equal to, this minus is a plus. This minus is a plus, so it becomes a positive 5. Plus or minus, square root, right, is better. The square root. You see this negative 5 squared? You can't come back negative 25, guys. Let's just not make that mistake. This is wrong. The negative 5 squared means negative 5 times negative 5. Has to become a positive 25. Negative times negative is positive. Then this here now, you have to be careful because you're going to end up multiplying a negative value right here. This negative 4 times 3 is negative 12, you know. And then negative 12 times negative 6. Let me use a different color to emphasize it, to show it. You multiply this negative 4 times 3 first. That gives you a negative 12. Then you multiply that with this negative 6 times negative 6. The negative times negative here becomes a positive 72. So it becomes negative 12 times negative 6. That becomes a positive 72. So right here, we're supposed to have a positive 72. And then dividing everything again, everything divided by the 2a, which is 2 times 3 is 6. But I go to that so far? But okay?
Yes, sir.
I want you all to get it. Perfect. You have to move past this. We're going on to new stuff tomorrow. We're moving ahead. All right. So I'm highlighting the mistakes here. Then now we're gonna go x equals, and rewrite this now. This 5 plus or minus, this all becomes 97. Square root of 97 and dividing all of that by 6. So you reach a final line, we're going to use the plus to get one root and the minus to get the other root, two values. So let's go. So we're going to have x equals 5 plus the square root of 97 divided by 6, or x equals 5 minus square root of 97 all over 6. Now, if you have one of those textbook display calculators, you can type this in the calculator exactly as it is there and save time. Same thing with this one. Type it in the calculator. That's why it's very important for you to get one of those calculators that you can type this in it and it looks exactly like this. I don't like the calculator with a little slash thing. With a slash or little thing looking like, I don't like those. Throw those calculators away from me, please. Get a good calculator.
Hey, what's the name of the good calculators again?
What was it again? Let me see if I can find another 4. I sent it in the group. I sent it in the group.
Sir,
I sent
FX82 MS, that one there?
MS is ES. I have
ES.
ES 300, you have 300 ES. I have 82 ES. I think they've started FX. A very good one is the Class Whiz. Class Whiz. If you get this one, you're nice. Class Whiz. That's like the boss one, the Class Whiz. That one you use it all the way up to the sixth form. All right, but I send it in the group. All right, I think this is the name of it, of the calculator that you want to get. All right, get a good calculator, please. But anyone that can actually type this as it appears here will be good enough. So let me bring up my calculator now and show you what I'm talking about. I want my calculator to show it exactly as it appears there. I want to see the fraction, numerator and denominator. I want to see the 5 plus. I want to see the square root. I want to see the 97. I want to see that over 6. That's how I want it to appear in the calculator. That's how I want it to appear in the calculator. The question said 2 decimal places. So that's 2.47. That is it. 2.47. And the other one is with the minus. Changes to a minus. Negative 0.81. So if I go back to the first one, the plus, it is 2.474896 and so on. The question wanted only 2 decimal places. Right? These 2 decimal places. So using this 4 to correct those 2 decimal places. 4 cannot change the 7. 4 cannot change the 47. Right? So this comes back as an answer, 2.47. So that's 2 decimal places. Then the other one, the other answer with the minus on the calculator is negative 0.80814 and so on, right? Again, I'm correcting to these 2 decimal places. Look at it. These are the 2 decimal places, 2 places after the decimal point. I'm using this 8 right here. To correct that 80. So it becomes 81 after decimal point. The 8 will increase it. So some persons did not correct properly, but I was not focused on that in the class, so I allowed it. You have to correct it. So the correct answer is actually negative 0.8. 0.81 is the actual correct answer. So these are the actual 2 answers that you're really supposed to get. These 2. So persons who put 80 in the exam, you lose a mark. I would not have corrected it properly, but I did not focus on that in the classwork. I allowed it because I really wanted to focus on the quadratics method and so on. All right, there's a time and place for everything. All right, so that ends that class activity right there. How was your body good?
Yes, sir.
Yes, sir.
All right, so I just want us to maybe run through the paper that I sent you last night. There's a couple questions on it. All right, just run through that paper quickly. I sent you last night. And when I send you work to do, please do it. When I send you work to do, I want you to do it. It's not a joke thing. All right, it's not a joke thing. When I give you work to do, you are to do it, please. I think I sent you this paper last night, 2018, and I asked you to do just a few simple questions. This one and this one under here, right? And then I told you to do 8B as well, right? On the same paper. That's all? 8B. I also told you to do 8B on this paper. Let's see. 8B, 8B, 8B. No, not this paper. A different paper gave you 8B. I check back. But I know that I gave you, maybe I gave you 8B on a different paper. Let me check. Hold on. Let's check quickly. Oh, just 2A and 2B I gave you. Oh, I gave you 2023. All right, so I give you 2023. No, lie. Let me see what I gave you. I just want to do what I gave you last night. Today. All right, I give you two papers. I give you this paper and I give you 2023 paper. All right, let's run through them then. All right, and then we're gonna finish after that. So this is some additional practice, guys. Just to show you the actual past papers. I like to show you actual past papers. So this is an actual past paper from 2018, right? So you can see that the things that I'm teaching you, the things that we're doing in class, the level of work that we're doing is consistent with the level of work that you get on the exam paper. That's what I want. That's why I want to give you past paper questions. So you can have confidence in what we're doing, right? And you see the importance of actually learning what we're doing because yes, I'm teaching you exam level stuff. I'm teaching you things that will come on exam paper. So here's one. This says factorize completely. See this word? Completely is very important. Means that you cannot stop in the factorization process. You have to factorize all the way down till there are no factors left. There's no further factorization possible. That's what the word completely means. Factorize completely the expressions. So this one, firstly, is the difference of two squares. See, I gave you the one in the class, and see, you get back one on exam paper here. I like to give questions, difference of two squares questions with a one. I like to do that, right? And then this now can be expressed as a perfect square as well. So if I were to express this as the difference of two squared, it would become equal to 1 squared. That's a 1, writing that as 1 squared, minus, now this expression as a perfect square, I'd have to write it as 2h all squared. Some persons put it as 4h all squared. So let us learn from the mistake, right? You have to put the square root of the 4 inside here. But you're squaring it back. All right? And then the square root of the 8 squared in here, which is just the h, but you're squaring it back. That is it. Notice in the form of the difference of two squares. Let's remind ourselves of the rule. Again, every time, more maths equals better maths. A squared minus b squared equals the difference of the numbers a minus b times the sum of the numbers a plus b. So the difference of the numbers times the sum of the numbers, as simple as that. This becomes equal to the difference of the numbers. This is the a and this is the b. So 1 minus 2h times the sum of the numbers, 1 plus 2h. And that is it, done. 1 mark for written up. But we want the 1 mark. Don't make no sense to give away that 1 mark. 6, you don't really give half mark, you know, guys. So if you get 1/2 of it right and get this part of it wrong, don't believe you're gonna get half mark. 6, you don't really work with a half mark. So it's a whole mark or not. This question is the whole mark you need to get. All right. Then we'll come down to here. This one, I say 4 terms there. So you must be thinking about the difference of, you must be thinking about factorization by parts. Your answer, when it is complete, it will look something like that 99% of the time. When you get a 4 terms expression like that to factorize, your answer will look like that. When you finish, it's normally a 2 steps process. Just like we're doing the quadratics, and we get the 2 terms in the bracket first, and then we'll do the next line. Same thing here. So what you do, looking for your highest common factor in the first 2 terms here first, and you're going to factorize these 2 afterwards. So these 2 is this, inclusive of the minus sign, and then you have this one is these 2. So we're going to go the highest common factor in the first 2 terms right now is just a q. Q. So you factor the q out of these 2 terms first. Inside the bracket, out of this, you're going to be left with a p. And you factor q out of this, you're going to be left with a minus q. What did I say? I always put back the p minus q over here first. Put back the bracketed term over here first. I'm going to put back the p minus q first, just to be safe. And then in between here has to be a plus value or a minus value. How do you know what it is? I can, for example, divide this minus 3p by the p inside here, and see that I'm left with a negative p, negative 3. Or you could divide this positive 3q by the negative q. See? 3q divided by negative q. That's going to become negative 3. Or, as I said, we could do the first values. The minus 3p divided by p. Minus 3p divided by p. I'm trying to decide what goes in here. This would work out. P's would cancel and leave me with negative 3. So it's a negative 3 that goes here, not just a 3. All right? And if you stop there, you're not complete. That is it. Some persons stop here, sir. No, you're not going to get the mark for it if you stop there. But the question said completely. Completely. Question said completely. So you have to factorize this again because this can be factorized further. What it is now that the p minus q now is a common factor, and they have been added with these 2 values, are joined by those 2 values. And so the next line becomes a combination of those 2, the q minus 3, times the common factor of p minus q. And that is it. Factorized completely. Everybody got that? But okay?
Yes, sir.
Say again, do it one more time, sir, please.
See one more time. Okay, more maths equals better maths. Let's go. One more time. So I'm saying there's 4 terms there. So 4 terms usually means you're factorizing by parts or by grouping. All right? And your end result most times is a double bracket answer with 4 values like that. Most times. So you're looking to get this as your answer. All right? In the end, that's what you normally have. So the process is just as how we do the quadratic. So you're going to factorize the first 2 terms and factorize the second 2 terms. But what is important is that whatever you get in the bracket here, you factorize these 2 terms, you must get the same thing in the bracket here. These 2 things in the bracket must be the same exact thing you want in the 2 brackets when you factorize. And you're going to have a value out here and a value out here. Some value out here and some other value out here. Something like that, right? So let me go through it now. So you go for the highest common factor in the first 2 terms first. If you look at those 2 terms that I've circled, the highest common factor is a q. So you factorize out the q first. So how do I factorize q out of this? Let me divide out the q, and I'm left with this p. And if this negative q squared, I factor out a q, let me divide out a q, I'm going to left with negative q. And because I know that I want the same thing in the bracket over here, and I'm going to just write it back first. P minus q, write it back first. Then I know that it is this expression that factorized down to this, because I'm trying to decide what goes in between here. It has to be a plus value or a minus value that goes in here. Plus value or a minus value that goes in between here. What value is it? I can know by looking at this, that this factorize down to the p. So it means that the -3 must be factored out here. Or you can start to do it by calculation. It's like you divide this by this. -3p divided by p. The p's would cancel and leave with -3. So -3 is coming in between there. All right. So that's how you can basically look at it. Or you can use the cube. You can say, okay, the 3q divided by the -q. The 3q divided by -q. Q's cancel and get 3 over -1. And 3 over -1 is -3. Again, -3 coming inside here. Anyway, you want to look at it. Right now, it is easier to see that is -3 using this and this because the p is inside here, the -3 is outside here. All right, I'm just showing you the reverse option. In any case, this is -3. And as I said, no, don't stop there because this can be factorized further. If you stop there, you're going to lose marks. But the question said completely. P minus q is now a common factor. And they are being added with this q and this -3. So you're going to put them all together. So it's q minus 3 times the common factor of p minus q. And that is it. If you put the p minus q in front, and write p minus q in front of q minus 3, it don't matter. It's correct, it's correct. It's the same two factors. This is this, and this is that. Same thing. So those are the two factors. All right, so let me take out this one. That is it. Better? First, you ask me to repeat it. Better?
Yes, sir.
All right, good. So that was 2A.
Yes, sir.
Yeah, beautiful. 2A and 2B, I said, right? Oh, I also asked us to do this one down here. All right, let's do this one. So this one, you want to make y the subject. When something says solve, the word solve in maths means you must find the value of the unknown quantity. That's what the word solve means. Solve means find the value of the unknown quantities in the equation. So you want to find out what y is equal to. What's the value of y? To find the value of y, essentially can transpose away the 3 over 2 and leave y as a subject. Multiple ways to do it. I'm going to do the shortcut way. This side is basically, I can get rid of this 2 by just multiplying it up here. Get rid of this 3 by dividing it under here. So I can cross multiply and cross divide. So because this 2 under here is dividing, I'm going to multiply it up here. Because this 3 up here is multiplying on the top, I'm going to divide it under here and leave y as a subject. So the y becomes equal to 12 times 2. 12 times this 2, that's what I get that. And then this 3, I divide it under here. 12 times 2 over 3. Well, 12 times 2 is 24. 24 over 3 is 8. Or you could say 12 divided by 3 is 4. 4 times 2 is 8. Anyway, take it. Y is equal to 8. That is it. All right? Now, some persons do this work and them do a lot of crossing or cross. I don't like to cross out the work. I don't like to do the mathematics and be crossing out. I like prefer for everything to show as it is there. Some person will come and cross out 3, they multiply both sides by 2, for example. And then I cross this out and cross it out. And then divide both sides by 3. And divide the side by 3. I cross it out and cross it out. Cross it out. And I have all this crossing all over the place. I don't like that. You have to learn to do the mathematics clean. It just shows a control over what you're doing when you're able to do it clean like this and don't have all those crossing all over the place. You get me? So you're not going to penalize you for it, you know, but I just feel like, you know, whoever is marking your paper is more appreciative if they can see everything clearly. It makes for easier marking and you get your marks easier. You want to get your marks as easy as possible. You want somebody to see your work and give you the mark without having to think to give you the mark, whether to give you the mark or not. Because they might just not give it to you, for whatever reason. So try to practice to do your work clean and clear. Remember, it's a human being that is reading it, not a machine. So you want to make it clear. Just always remember that there's somebody that is looking at your work to give you the grade. So the cleaner it is, the better. All right, and lay it out nicely. Lay it out nicely. Don't have it jumble up all over the place. Make it easy to read. Whoever is marking a paper must be able to read your work easily and understand what you write. Just always think as if you're doing the work for somebody else. You're not really doing it for yourself. That is how you present your work. You're presenting it for somebody to be able to read it. So you write clearly, space out your work nicely, set it out neatly. All right, let's continue. Everything important. Then we have this to solve. We have this one to solve. Now, let me just tell you something now. I'm not going to do it today, you know. Maybe when we are able to factorize these. It's like how they give me this to solve, and they don't tell me about a decimal place, not like that. I know that this can be factorized. Then I want to point out something to you before we go on. All right, I'll just show you today. Now, when you're factorizing a quadratic and the n values are prime numbers as they are here, it's very easy to factorize them. Because the factors of this 2 is only 2 and 1. And the factors of this 3 is only 3 and 1. So these are the values that must end up in the brackets. 2, 1, and 3. You know that right away. Because the factors of 2 is only 2 and 1. Factors of 3 is only 3 and 1. So when my n values are prime, like this, I really don't need to do the 2 times minus 3 process enough. Right? I don't need to do that. I'm going to show you this time how I can factorize this without the need to do that. Simply because the n values are prime. The only factors of 2 is 2 and 1. Only factor of 3 is 3 and 1. All right? So watch this now. There are a couple of things that you need to consider, but let me just show you. All right? And maybe you'll learn something from this. I want to factorize this expression. So I'm going to set it up. The factors, and just drop the values in there. I'm gonna do it wrong, and I'm gonna do it wrong just to show you how you can just start to do it almost like trial and error. So the factors of 2x squared can only be 2x and x. Only, can't be anything else. And those factors go here and there. They can only be 2x and x. 2x and x are the only factors of 2x squared. Then the only factors of the 3 is 1 and 3. Remember, this is negative enough. It's when the sign is a negative, you're going to have opposite signs in the bracket. Like you have plus and minus, or you have minus and plus. You must have opposite signs in the bracket. Why is that? Why is that? Let me tell you why. Because this third value is a product of the value here and the value there. All right? So, let's say the factors of this is only 1 and 3. Let's say I put the 3 here and the 1 here. Look what I know again. I know that the far product and the near product must add to give me this middle term. Mute your mic, please. I want to listen to me carefully. I'm showing you something now. Right? I'm just telling you now, you're not going to master it yet, but I'm just introducing it to you now, the shortcut way of factorizing. Right? Especially when the n values are prime like this. All right? You can literally look at it and know what the answers, what the factors are. So it is the far product and the near product that add to give me the middle term. All right? Additionally, you see this, when the last term value here is negative, given that the first value is positive, if the last value here is negative, it is actually the difference between the far product and near product that must be the middle term. The difference. That's what the minus here tells me. This minus. Tell me that is the difference between the far product and near product must be the middle term. Now the far product right here to now is 2x. Mute your mic, please. The near product is 3x. The difference between 3x and 2x is 1x. But the middle term is 5x. So it means then that I don't have these values the correct places. They have to be the other way around. They have to be the other way around. So see here now, they have to be the other way around. So this 3 must go here, and this 1 must go here. So I'm going to switch them around now. I'm going to put the 3 here instead and put the 1 here. I'm going to test the far product and near product again. This time, the far product out here is 6x. And the near product right here so is 1x. 6x and 1x. The difference we want. Why do I want the difference? Because this is a minus. When this is a minus, I want the difference. When this is a plus, I want the sum of the far product and near product. So the difference of the far product and the near product, that must give me the middle term. So the difference between 6x, the difference between 6x and 1x right now is 5x. So I know that these values are positioned the right way. Now it's just a matter of what sign go inside here, plus or minus or plus or minus. That's what it is. Now what is now? Since my middle term is positive, the larger of my two products must have the same sign as the middle term. Okay, it is the far product and the near product that add to give me the middle term. So I want the far product, the larger one is the far product. I want the far product, which is 6x, to be positive, and the near product to be negative. In order for the far product to be positive, I have to put a plus there, so. And so the minus must come there, so. And those are the factors. So these are the factors. So I have to put a plus here and a minus here. And I can double check it. Okay, I can double check it quick now. Look. Mute your mic, please. Somebody's mic is open. This times this. Give me the 2x squared. This time this, the negative 1 times the 3. Give me the last value, which is the negative 3. And remember, as always, the middle term is the sum of the far product and the near product. The far product is 6x. The near product is negative 1 times x, which is minus x. These give me the middle term of plus 5x. So it means that those two factors are correct. But understand that? It was the first time I'm doing it. I'm just giving it a quick explanation. Think you understand it? I'm going to do it one more time.
Yes, sir.
I'm going to do it one more time, but I'm going to do it a little more quickly, right? But don't worry about if you don't understand it. You can use the split in the middle term method and do it. But I'm just showing you that you can actually factorize them quickly without doing the splitting of the middle term. I'm just showing you with this example, especially when the n values are prime numbers, as they are in this example. They are prime numbers. All right? Let me just show you again quickly. I'm going to go a little faster now. Watch it again. So the only factors of 2x squared are 2x and x. I must go as the first values in the 2 bracket. 2x and x are the only factors. All right? So I'm going to write the 2x and the x first. Then the factors of this 3 go in here and there. And what I realize is that, what I know is that the far product and the near product must give me the middle term. The far product means the product of the 2 far values and the product of the 2 near values. They add together to give me the middle term. And the only factors of 3 is 1 and 3. So I'll put the 3 here and put the 1 here. Then my far product is 6x. And my near product, 1 times x is 1x. Then my middle term is a difference between the far product and the near product. Why is it different? Because this is a minus. When the last value is a minus, given that the first value is positive, this is on the premise that the first value is positive. And when the last value is negative, it means that it's the difference between the far product and the near product that gives it the middle term. The difference. The difference between 6x and 1x is 5x, which is my middle term. So I know that these values are positioned the right way. So now it's just a matter of where I put the plus, what sign go in between here and there. Now, because My middle term is positive. I have to give the larger of my far product and near product the same sign as my middle term. So I have to make my far product positive. To make it positive, I have to put the plus here. And the plus goes there, then the minus goes here. And that is it. So I'm putting the plus right here and the minus right there. And those are the two factors. But let's go to the other method quickly to show you how we factorize it the other way that we have learned. Some of the mic is open. Some of the mic is open. Right. So if I'm going to do it the normal way, I'm going to multiply the 2 times the minus 3 or the process way. 2 times negative 3 equal negative 6. I want 2 times negative 3 equal negative 6, not negative 6, negative 6. I want a factor of negative 6 that add to positive 5. That's what I want. The middle term is positive 5 in the coefficient. So factors of a negative number, one must be positive and one must be negative. I'm going to give the larger one the same sign as this. It's a 5. First two factors of 6 are 1 and 6. And the larger one have the same sign as that. So make this one positive, make this one negative. So 6 and minus 1 is a positive 5. So we'll find it already. I'm going to split this 5x into these two values. All right, let me move this away. Move it down here, sir. All right, I'm going to split that 5x into those two values. All right, let me put them back and make it a little cleaner. I'm going to do it like this. Use a different color. I'm going to split. Let me use this. I'm going to split this 5x using this value.
Sir,
This value, yes?
quick question, just to double check. It's okay if we use the quadratic formula to solve it too, right?
Yes, yes, yes. It's okay to do
All
that.
right.
Yes. It's okay to do quadratic formula, yes. But we cannot get away from factorizing now, guys. Remember, factorization is a question on the paper. So I have to learn to factorize. So don't just say, all right, we have a quadratic formula I can use. You have to learn how to factorize. You have to learn how to factorize. You have to practice it. So if you're not comfortable with it, you get comfortable by practicing. All right, that's how you get comfortable. So I'm going to split the 5x into those two. I'm going to put the 6x in front. So the expression then becomes 2x squared plus 6x minus 1x. That's it. So the plus 6x is for here, the minus 1x is for there. And then back the minus 3, this minus 3 comes back equals 0. Then I'll go for the highest common factor in the first two terms. It's 2x. All right. No, yes, 2x, right? 2x, right? Good. So it's 2x. I'm going to get 2x bracket. Out of this, I'm getting an x. And out of this, I'm getting a plus 3. And you put by the same thing in the bracket over here, so x plus 3. So if you have a minus 1x and you factor in the x, means that you must have factored out the minus 1 right there. Minus 1 equals 0. So then now, let me shift this down again. Then now, this becomes a common factor, and you put in these two on a common factor now. So you're going to get 2x minus 1. Right, that's better. 2x minus 1, that's this and this, times x plus 3 equals 0. So you get the same two factors, 2x minus 1, x plus 3. And from here, I can write the answer now. If this equal to 0, this factor equal to 0, then what will be the x? The x will be equal to, take the negative 1 and carry it to it, become positive 1. And then I would take this 2 and divide it under here. So I get a half. Or if this one equal to 0, if x plus 3 equals 0, Then I would have to do is take this negative 3 and carry it over, and I will get negative 3. Take this positive 3 here and carry it over, and then I will get negative 3. And those will be the two answers right there for that question. All right, so yes, quadratic formula can be used, but we have to practice factorization, guys. So you could get the same answer with factorization, no problem. All right, I think that was it for that question. What time is it now? 11:52. All right, so let me see if we can run through next paper. I think it was 2023 that I gave you last night. Run through it and never call it a day. Quick and fast. 2023, which paper was it? June 2023. What was it? Yeah, January 2023. Let me get it quick. January 2023. January papers are here. 2023. It's right here. I'm going to run through this one quickly and we'll call it a day. At least the video will be there. You can go back and watch it. All right. I have an appointment. I have an appointment. 2023. I said to do a question 2B, right? Right here. That's what I said, 2B. All right. So they give us this to factorize. Let's do it quickly. This was our common factor of y initially. Y alone is the common factor. So this factorizes into y bracket. Y out of this limit and x. Y out of this limit and negative y. Can't factorize any further. This is now the difference of 2 squares. So this factorizes into x minus y times x plus y. That's what this factorizes into. And then now, let's say hence simplify this expression. So you realize that this numerator is this one, which was factorized into that. And so hence means that you have to use these results, you know. That's what hence means. So this numerator becomes this one, which is y bracket x minus y over, and this is the denominator, the difference of 2 squares there, which becomes x minus y times x plus y. And then if you look now, you see that this and this is the same. Look at it. This is x minus y, x minus y. So they cancel each other. They cancel each other, those two. All right? So this and this cancel. I don't like to mark out stuff. Those two cancel. So I'm just left with these. I'm going to draw a line through them this time. So this expression cancel with that expression. I just don't like to mark out stuff. All right? And then so this becomes the y up here remains, and the x plus y on the denominator remains. That is the answer. But understand that? Understand that, guys?
Yes, sir.
Say yes?
Yes, sir.
All right, good. That was 2B. Where's that? I said the 2C though. All right, so 2C was a kind of little bit of a challenge on this one. 2C. 2C. All right. So this one now, let me see. This one says the diagram below shows 2 rectangles, M and N, with their dimensions expressed in terms of X. Given that the difference between the 2 areas of the rectangle is 64, show this. So this was that kind of challenge question that I gave you. So the difference of the 2 areas is 64. So like we want to find the area of M and the area of N and subtract them. So we can set up like this. Area of M minus area of N equals 64. That's what they said. The difference of the 2 areas is 64. What will be the area of M? It will be this dimension times this dimension. That's what it will be. Multiply the 2 dimensions. So it will be x minus 3 times 3x plus 4. That's this one. This times this. And then minus product of these 2 dimensions now, which is now another x minus 3 again, times x plus 2. And that is equal to 64. So this now can be done multiple ways. I can treat this as a common factor now, you know, this. And put these 2 together with this minus sign. Can do it that way now. Let's do it that way. More maths equals better maths. Or I could expand this out and expand that out now, but I'm going to do it this way that I just told you. So I'm put these as a common factor, the x minus 3. And then now I'm going to end up in the bracket with this minus that. Because if I factorize x minus 3 from this one, if I factorize x minus 3 from here, I'm going to left with this inside the bracket, which is 3x plus 4. And then from this side, if I factorize the x minus 3 from these two over here, I'm going to left with this minus this expression, minus x plus 2 in the bracket. And that is all equal to 64. I'm going to consolidate in here, so now watch this now. X minus 3 bracket. Inside there, watch it carefully now. It's 3x, let me use a different color. It's 3x minus x. 3x minus x is 2x. 3x minus x is 2x. I'm going to have 2x here. And then, in terms of the whole numbers, is 4 minus 2. 4 minus 2 is 2. So I'm going to have plus 2. That is still equal to 64. Remember now, we're working towards this equation now. So what I'm going to do now, I'm going to expand this side and carry over the 64. So how do I expand this side? Let's go step by step this time. When we get a little bit more advanced, I'll do this a little bit more quickly and use some shortcut method, right? But for now, I'm going to go step by step. For the first time we're doing stuff like this, right? So to expand this now, I'm going to multiply this x by this 2x first. This times this first, right? That's going to give me 2x squared. Then I'm going to multiply the x again times this positive 2. I'm going to get 2x. I'm going to get plus 2x. Then it's time to use this now. I'm now going to go this negative 3 times this and then negative 3 times that. The negative 3 times this first is negative 6x. And then the negative 3 times the 2 give me negative 6. And then this 64, I'm going to bring it over this side and subtract. Well, minus 64 equals 0. But go to that so far? But okay with that?
Yes, sir.
Yes, sir.
Yeah.
All right. So putting like term together now. This is the only squared term there, this one. So I'm going to write about the 2x squared. Then this and this give me negative 4x. 2x minus 6x is negative 4x. Then minus 6 and minus 64 give me negative 70. Minus 64 and minus 6 is minus 70. This is all equal to 0. Then each of these can be divided by 2. So I can divide 2 by 2. So I can divide this by 2, divide that by 2, and divide that by 2. And divide this 0 by 2 as well. So I'm dividing everything by 2. I'm dividing 2 by 2. When I divide this by 2, the 2's cancel. I'm left with x squared. When I divide this by 2, 4 divided by 2 is 2. I get negative 2x. 70 divided by 2 is 35. But it's negative. So I get negative 35 equals 0. And this is the same expression that they told us to show. See it here? This is the same thing that they told us to show. Therefore, we can say it was shown. And that is it. We showed it. All right, guys. Question like this, you just go and do it over by yourself. It's in the group. The question paper is there in the group. Now let's see me do it. I'm going to send the video in the group. Try it for yourself. All right, get the practice in. And you can watch the video and go step by step and try to do it by yourself. All right, number 8 now on the same paper. Number 8 is a quadratics. I think it's just to fill in some values on a table and draw the graph. Easy, easy stuff. Right here. So remember, the quadratic graph is a symmetrical graph, right? I can actually put in these values without doing anything, you know. Look, the values are symmetrical. The values are symmetrical. This is a smile shaped graph, go like that. So it has a minimum point. That's smile. Square term is positive. This is the function right here. Same thing, right? Look at the values. So the 0 here. All these values increasing by 1, the x values. The interval is the same. All those values increasing by 1. All right? So these two values correspond to each other. So since I come this way to a -2, I'm going to go that way to a -2 right here. So this is a -2. I can tell you from now that this is going to work out to be -2. And when I go to the right of this one, on this side, I go to 4. So when I go to this way, I'm also coming to 4. So this value is a 4. When we're working it out, I know that this value is a 4. That is it, because the values are symmetrical. The values are symmetrical. Then my line of symmetry is going to be right between here. My minimum value is not -2. Remember, the -2, the minimum value cannot occur at 2 different points. It just has to be a value less than -2. My minimum value is at the point where x is equidistant between 0 and 1. Halfway between 0 and 1 is a half. So the x value at my turning point is a half. Halfway between 0 and 1 is a half, 0.5. 0.5. You could also average the two roots. Remember, the roots are where the y value equals 0, right? So these are the two roots. These are the two roots. The roots are the values on the x-axis when the y value equals 0. So those two values are the two roots. If I average them, I get a half as well. Let me average them and show you. -1 plus 2 over 2. -1 plus 2 over 2. -1 plus 2 is 1 over 2. 1 over 2 is a half. See? The x value turning point is a half. Multiple ways to get it. All right? And then to find the y value now, to find the y value down here, that corresponds to a half. In other words, the yt value. Find the yt value. We can take the half and put it in the function for the x right there. So that will become, if I put this value inside here, I'm going to get a half squared is a quarter, 0.25, minus a half, 0.5, minus 2. So that's minus 2.25. That's what it becomes. So that is xt. No, that is yt. Yt. That's when I put the xt value in the function, that's what I get. Because this 0.25 minus 0.5 is negative 0.25. And I'm subtracting this 2 again. So this is the result. So this is negative 2.25. So my minimum point is xtyt, which is 0.5 negative 2.25. All right. Now, I want you to actually do these calculations for me to get these. Do them for me as homework. Calculate these values that I put in by observation, by plugging the values them in here. Let me do it. Let me do it for you. Let me just do it for you one time. So for the value right here, for this one, I'm going to put the -2 in this. It's going to become -2 squared. That's the x squared. Minus a -2. That's when you minus the x right here. -2. This becomes a +4. Minus here, so becomes a plus. So you get +2. And then minus back this 2. See? That works out to 4. This 2 wipe out this 4, that equals 4. And then over here, for this 0, this one obvious, right? Because if I put 0 inside this and inside this, it was gone. And so the y value is going to be -2. See there, -2 is left. That one kind of straightforward. So you can see, but as I said, we could have gotten it by observation. So that's why this value now is 4. So it's about plotting those points on this graph now, and sketch a graph. You notice they didn't scale it up for us, so we have to scale it up for ourselves. All right, so the x value is going from -2 to 3. And they put the y-axis here, so. All right, so we can maybe go 1, 2, 3, -1, -2. So every 2 centimeters is 1. So I'm gonna go 1, 2, 3, based on the graph that they gave us. This is the y-axis. So right, this is 0, -1, -2. And I think they told us a scale in this question. See there, 2 centimeters to 1 unit on both axes. So see that? 2 centimeters. See? 2 centimeters to 1 unit. Same thing on the y-axis. So that's gonna be 1, 2. Remember, each of this is a centimeter, and each block is a centimeter. 1, 2, 3, 4. Highest value is 4, yes. And the lowest value is -2. Actually, -2.25. So we're gonna go 1, -1, -2. -1, -2. All right, let's put in the values. Let's put in the points now. Let me use the blue. Put in the points. So the first point was -2, 4. -2 up to 4 right here. That's this point at the top, right here. -2 up to 4. Right, that point up here, -2, 4. The next point was -1, 0 on the x-axis, right here. Right here on the x-axis, -1, 0. This point was 0, -2. This one, 0, -2. That's on the y-axis, y-axis intercept, right here. Then it's symmetrical. They go 1, -2. 1, -2. 1, -2 is right here. Then going 2, 0, right? See, 2, 0. 2, 0 is on the x-axis again right here. And then 3, 4. 3, 4 is that point. So 3 here up to 4 up here. So 3, 4 is right up here. Then we have to put in this minimum point, guys. All right? When we look at it, the axis of symmetry is right between these 2 points, like this. The minimum point is on this axis of symmetry. So if it says a half, yeah, it's passed through a half. This is 0, this is 1, this is a half. X1 is a half. So the minimum point is on here. And I go down to -2.25. So we need 0.25. So look at this now. Each of these lines is 1. Is 0.1, sorry, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.91. So each of those lines is 0.1. So we need 0.25. So see here now, this is -2 right here, -2.1, -2.2. This should be -2.3. This is 2.3, 2.2. We need 2.25. So we need 2.25. 2.25 is halfway between 2.2 and 2.3 negative. So it means that our turning point is right here, 2.25, right here. Halfway between the 2.2 and the 2.3. All right, let me take this off now. That's where it is, right? So that's our minimum point. So when you draw the graph of carrot down to here, I make it turn down there, so. You can sketch it now. Let's sketch it. So it's gonna sketch it now, guys. Sketch it now. I'm gonna go like this. Let's go again.
You know, y-intercept. Oh, to remove the 2.
That's it. So sketch with the freehand. Don't make it rough like me, you know. Just that I can't draw a smooth curve with this device. But one important thing is that you must bring it down to here. Don't come across here with it. Otherwise, you just lose marks. Remember, it has a one minimum value, which is right here. One minimum point. So you have to make sure you bring it down to here. All right, and then you go back up. That is a curve. So this question is really, I'm gonna give it a 6 marks if you bring it down to here. Remember now, there's no indication in the question that you must do that, you know. No indication that you must do that. So you have to know, it's a knowledge-based question. This question is testing your knowledge of a minimum point. Testing if you know that a minimum point exists and how you find it. And to know that this cannot be a minimum value. But the minimum value cannot occur at 2 points. The minimum value occurs at only 1 point, at the vertex point only. That is your minimum point right here. The minimum point is on that axis of symmetry at the vertex. This red line is the axis of symmetry. And the minimum point is on it. The minimum point is negative 0.5, negative 2.25. So the minimum value is this. That's the lowest Y value on the graph, negative 2.25. So you have to learn, you have to know that you have to put that point in. Question did not even give you a hint to put it in. The section 2 question, this is going to test your knowledge of that. It's a whole 6 marks for this graph. And I bet you that maybe to put in this part of it down here is 2 marks of the 6 marks. Or maybe, yeah, 2 of the 6 marks. Just to get this point down here, so get that part right. A lot of pros are going to just come straight across here, so, and don't put in this part, you know. But they're going to lose the marks because they don't see it in the table. But you have to know that the axis exists, axis of symmetry, and the vertex exists. And you have to have that knowledge of a quadratic graph and know that you have to include it, even though they did not give it to you. They did not give you a point on the graph to put it. You have to work out this point, those values, and know that this point has to be included. The vertex point has to be included. All right, guys? Very good?
Yes, sir.
So this is a good question. This is a good question for you to redo. This is a good question for you to redo and get it right and make sure that you work out this point down here and include it on the graph. This is how CXC like to set this question when they ask you to draw the graph. They don't even mention the vertex in the question, but you're expected to put it in. Even if they don't mention it, they don't even hint at it, they don't even give an indication that you must put it in. You must know that you have to put it in. See, it's 4 of 6 marks to give for this question. That's a lot of marks. All right, guys, that's it for today. More maths equals better maths. Study hard, pass easily. Good. So I'll see you in class tomorrow and Monday. Oh, by the way, forgot to tell you.
Welcome class tomorrow.
Huh?
Oh, sorry, sir.
You have class tomorrow. You have class tomorrow. I'm gonna have to break class this week because I have to go overseas, emergency. I have to go overseas for a week, so I'm gonna have to break class. I'm not having class Wednesday this week. So after I have class tomorrow, we're not gonna have class again, face to face, until next week. I'm gonna see when I'm away if we can have some online class, just to have some revision. But I'm not gonna teach anything new in the online. If we're having any online class, it's just revision and practice. But I have to have an emergency. I have to go overseas for quickly. So
Yes, sir.
After leaving on Wednesday. So I'm gonna send a message in the group about it, though. All right. And you,
All right, sir.
So we have class tomorrow. We won't have class until face to face until next week, Wednesday. All right.
All right, sir.
I'll say it in the group. All right, guys. So see you all. We'll talk.
Yes, sir. Wonderful study, sir.
All right. Remember,
Yes.
redo the question. Remember, you have to redo the questions. All right. Redo the questions. All right. Bye, everybody.
Bye, sir.
Bye, sir.
Bye bye. Bye bye.